Today I'll be talking about optical instruments, specifically telescope by Lara Tariq Tanjiwan. And now I will give you an introduction about optical instruments. Optical instruments are the devices which process light wave to enhance an image for a more clear view. We have the three main types of optical instruments. We have the cameras, microscopes, and telescopes. Using an optical instrument such as magnifying lens or any complicated devices like microscope, telescope, usually make things bigger and helps us to see in a more detailed manner, a more detailed view. The use of converging lenses makes things appear larger, and on the other hand, diverging lenses always gives you a smaller image. And now let's talk about the three main types of optical instruments. We have cameras, telescopes, and microscopes. Let's take a look about cameras. Cameras are optical devices which focus light on a piece of film to record and allow user to record an image of an object, either on a photo paper or digitally. All cameras form images in the same basic way. And if you're wondering which lens is used in camera, convex lenses. Microscopes. Microscope is an optical instrument which allows people to see enlarged images of objects that are very small and tiny, such as we have mineral samples, or we can see animals or plant cells, typically magnified several hundred times. We have many types of microscopes, but here are some. We have the compound microscope, the stereo microscope, digital microscope, the USB computer microscope, the pocket microscope, the electron microscope, the scanning probe microscope. And finally, we have the telescope, which is my main and most important topic or title for this video. So let's move on to learn more and discover about telescope and what is telescope and how it is used. A telescope is an optical instrument which allows people to see objects that are far away and aids in the observation of remote objects by collecting electromagnetic radiation. Or by other wording, we can say a telescope is an optical instrument that makes distant objects appear magnified by using an arrangement of lenses, or we can say a curved mirrors and lenses or various devices used to observe distant objects by their emission, absorption, or reflection of electromagnetic radiation. There are three main types of optical telescopes. We have the refractive, reflective, and catadioptric telescopes. Refractive or refracting telescope, also called a refractor, is a type of optical telescope that uses a lens as its objective to form an image. The refracting telescope design was originally used in spyglasses and astronomical telescopes, but it also used for long focus camera lenses, such as the one that was invented by Galileo, which use an objective lens and an eyepiece. The image is focused at the focal point and allows the observer to see a brighter, larger image than they would with their own eye. Reflective or reflecting telescope, also called as reflector, is a telescope that uses a single or combination of curved mirrors that reflect the light and form an image. Sometimes a secondary mirror redirects the image to an eyepiece. Other times the image is recorded by a sensor and observed on a computer screen. The reflecting telescope was invented in the 17th century by Isaac Newton as an alternative to the refracting telescope, which at that time was a design that suffered from severe chromatic aberration. And if you're wondering what's chromatic aberration, is an optical aberration in which an image has colored fringes caused by differential refraction of light of different wavelengths. Catadioptric telescopes are optical telescopes that combine specifically shaped mirrors and lenses Y to form an image. This system has a greater degree of error correction than any other types of telescopes. The combination of reflective and refractive elements allow for each element to correct the error or the mistake made by the other. Their designs can have simple, all spherical surfaces and can take advantage of a folded optical path that reduces the mass of the telescope, which make them easier to manufacture. Catadioptric dialites are the earliest type of catadioptric telescope. They consist of a single element refracting telescope objective which is combined with a silver-backed negative lens. Catadioptric combinations are used in focusing systems such as searchlights, headlamps, early lighthouse focusing system, and many more. Let's change the beat a little bit. A lot of people ask this question: is the image from a telescope real or virtual? So basically, the telescope is designed so the real inverted image created by the first lens is just a little bit closer to the second lens than its focal length. As with the magnifying glass, this gives a magnified virtual image. The final image is also inverted compared to the original object. And now let's state some facts and new amazing informations about telescopes. Until the invention of the silver-baked mirrors, refractive mirrors were the standard for use in telescopes. This was because of the highly corrosive nature of the metals used in olden mirrors. And since then, reflective mirrors have replaced refractive mirrors in astronomy. And now let's talk about the first telescope. The way that lenses could magnify or sharpen images have been understood since the days of ancient Greeks, but it was only when eyeglasses were made in Western Europe from the 13th centuries onward, and since then the quality of lenses started to improve. And as the quality of lenses improved, the possibility of using them to look at the stars began to occur to people. After that, the first known optical telescope to be built was in Netherlands in 1608. The largest optical telescope in the world is in Hawaii. It's the 10-meter W.M. Keck telescope. And now, let's take a look about the diagrams. First, we have the refracting and reflecting telescopes. Starting off by the refracting telescope, as you can see, we have the pupil of the eye on the left side, the focus in which the incoming light is bent into the bright point. We have the objective lens which gathers the light and bends it into focus, and on the right side we have the incoming light, and finally we have the eyepiece which brings the bright image from the focus and magnifies it to the size of your pupil. A refracting telescope uses a convex lens to collect and focus light. It uses another convex lens in the eyepiece to enlarge the image made by the first convex lens. Moving on for the reflecting telescope, first of all, let's see the part. Number 1, we have the incoming light. Number 2, we have the primary mirror. Number 3, we have the secondary mirror. And number 4, we have the eyepiece. So basically, a reflecting telescope uses a concave mirror. Why? To collect and focus light. The light then strikes a smaller plane mirror, which reflects the light into the eyepiece at the side of the microscope. The eyepiece is on the side so it does not block the incoming light or the light that is coming. Basically, a convex lens in the eyepiece enlarges the image. And finally, with the catadioptric telescope. So let's see the parts. On the right side, we have the eyepiece or the lens. On the second right, we have the eye. On the left side, we have the incoming light, which comes from the object. Below, we have the secondary mirror. And above, we have the corrector lens, focus, and the primary mirror. So basically, a catadioptric telescope combines both refractor and reflector to greatly shorten the body tube. and make a large aperture lens very portable. So at the end, let's summarize what we have learned during this video. So during this video, I talked about the 3 types of optical instrument: cameras, telescopes, and microscope, but my main topic was telescopes. We learned about the 3 different types of telescopes, such as the reflecting, refractive, and catadioptric telescopes. We list some interesting facts and informations about them. We also talked about the main purpose for telescope, in which it aids in the observation of remote objects by collecting electromagnetic radiations such as X-ray, visible light, infrared, and so on. Thank you so much for watching this video. Hope it was helpful and useful.